2013, I was diagnosed with a 10mm disc herniation at my L4-L5. That left me with debilitating sciatica for 2 years and prevented me from doing what I love. I lost 40 pounds of muscle. I was told by multiple surgeons that I shouldn't be squatting or deadlifting ever again. What's funny about this is that aside from benching, I actually never did lift anything heavy. I just kind of flopped around, didn't know what I was doing. I saw what other people did in the gym and just moved without any real intention or understanding why I was doing the movement. About 1.5 years after my injury, I met a CrossFit coach that, believe it or not, taught me how to break down my movement patterns into little things. I spent a year working on ground-based movements and dumbbells and never touched a barbell. Just like martial arts, if you want to get really good at doing some cool stuff, you have to focus on the basics. Why would that be any different with any other skill that we learn? I avoided surgery for my herniation and overcame numerous other injuries over the years as a result of working with coaches and guides. If you're someone that's struggling with pain and stuck right now, I encourage you, find a coach, find a guide. It'll make a world of difference.
Ladies and gentlemen, welcome to another episode of the Nerd Chronicles with your host Christian Paul speaking. And now we are in the exploratory data analysis section when it comes with the pre-trained lumbar spine stemming from our lumbar coordinate data set that we have worked on. In the previous video, we have actually did a deep learning analysis in regards to our coordinate data set, utilizing the images and seeing whether or not those images are actually well proficient. Now we are mainly focusing on the coordinates, on where those injuries and where those, degeneration has mainly took place, including those images that are mainly given. So ladies and gentlemen, we are now on Tableau here that basically show a graph, and one of the first CSV files that we have is the pre-trained coordinates in a CSV file, which will be shown with more information basically on the description box below. Alright, I just want to actually try and give you a quick heads up in regards to that. This is going to be the first one that we will be dealing with, and we will be dealing with the X versus Y on the pre-trained lumbar spine that have actually been mainly shown here. You're seeing all the coordinates, not just with all the locations with all the nodes that are within the spine, L1, L2, L2, L3, L3, L4, L4, L5, and L5, S1. The bottommost part when it comes to those types of discs. We also had them split up based on the types of images that have been shown. And you're seeing much of these locations, you're basically seeing much of a scatter plots that are basically shown between those areas. See where are those pain points and where those degenerative points have mainly took place between each section, between each location. And take note, ladies and gentlemen, this is only just in the pre-trained models that you see here, which is mainly grouped together in like some cases, giving some images, and others unfortunately are mainly spread out. This one is grouped together. This one is actually mainly clustered up together and see where most of the damage is made, or most of the degeneration lies between the patients that are mainly given within that competition study that have basically been shown. And y'all seen it all the way throughout. And this is only the pre-trained lumbar spine, ladies and gentlemen.
Ladies and gents, if we want to use the second derivative test, first thing we need to do is take the first derivative. Hello. Oh, okay. We have 2x plus 3, right? We can find the critical value. And again, I would recommend just a lot of times taking a look at this, x equals -3/2. Now, we could use test intervals and use the first derivative test, right, to determine if it's positive or negative, but that kind of takes a little bit of work. If we go ahead and take the second derivative test, all we need to do is find the second derivative, which is 2, and then evaluate the second derivative for f of -3/2 and determine if it's positive or negative. F double prime of -3/2 is going to equal 2. So we could say f double prime of -3/2 is greater than 2. Right? I mean, look at it, it's a line. Whatever number you plug into that function, what are you always going to get? 2, right? So it's always going to be positive. However, that doesn't tell us much unless we apply the second derivative test. The second derivative test says if double prime of c is greater than 0, that means the graph is concave up, then f has a relative minimum at the point c, comma, f of c. So we can say since f double prime of -3/2 is greater than 0, by the second derivative test, writing really bad, f of x has a relative minimum at, and we could write the points -3, or I'm just going to set it at x equals -3/2. And if they are talking about the point, then obviously you'd want to plug in what exactly the point is for that, right? You can plug in -3/2 into x. But I'm just going to say the x value and keep it short. So does everybody see my justification? Does everybody see how I gave a justification of the second derivative test? I also labeled the second derivative test, so there.
Ladies and gentlemen, now we're focused on the relative x versus the relative y on a pre-trained lumbar spine. And for those who know what the relative variable mainly is in calculus, a relative position stems from a combination of 2 points, stemming from a function within the 2 points that you see that's between the two, and basically on the activity of what goes on between the two. That's basically what a relative point mainly is, hence the term relative x, hence the term relative y. You can definitely look more of that up, definitely on your Google as well as your calc book, mainly in Calc 1. They'll give you further details when it comes to the relative derivatives, integration, the whole 9 yards, basically where relative x, relative points mainly come from. So, what we're seeing here in Tableau is basically on a group of estimates on where, on average, the degeneration mainly lies relatively within those patients and where they most likely will locate should a part of spinal degeneration mainly fail, regardless of causes. So you're seeing one axis, the LCs mainly bunched together in the L1, L2. All of them are mainly bunched together in the L1 section. The OSF definitely more spread out. Spider a little bit more bunched together. And T-seg is definitely mainly tightened. You see all the relative points that you see with one another. That's way far different than the regular X as well as the regular Y points. Now let's go focus on the second CSV file that we have that's given, that stems from the lumbar coordinate dataset. All right, ladies and gentlemen, we are now on our second CSV file stemming from our lumbar coordinate dataset that focuses more on the RSNA, right? On the improved RSNA that deals with CSV files, and now we're dealing with like the relative X and Y coordinates of where the spine degenerations have took place between those areas and between the patients. So here, what we're seeing here between, there's going to be some subsections between the L1, L2, L2, L3, L3, L4, L4, L5, and L5, S1. So you have your level conditioning your side, right? When you're dealing with the size of the conditions, you have the left neuriformal narrowing, you have the subarticular stenosis between both sides, and then you have the spinal canal stenosis that you see within those sections that's coming from the left as well as the right side, right? For each section that's given, you're seeing the distance of the relative Y and the coordinates of where many spine degenerations have taken place between patients, and he basically made accumulation of all the patients that had compiled and where those locations had mainly gone over throughout the whole data set, throughout the graph, and you're seeing a map of around more than likely an average of where the spine would normally degenerate, basically for patients really. But it can vary based on patient to patient. Here, this is what's been shown, all clustered up together between each side that's shown, left and right. It is literally insane. They're not fully spread out. They're literally clustered within one another down to a T. As you can see all the way here, you can see all the values that are mainly given, literally all the way throughout, right? And what this data shows, ladies and gentlemen, it gives a thorough insight for doctors to actually make their decisions on how to actually handle, spine degeneration or back pain or even like back injuries, on how to properly treat them and what are the best strategies as you mainly treat those types of injuries, either do PT or possible surgery, right? And this information here, as well as the learning information that we have in the video before, definitely do provide that type of information for the doctor to look at and make a firm decision. So with that, I might be doing another further video on this, on how to further strengthen your back to prevent yourself to being one of these statistics here, to prevent yourself being another statistic just like these patients, you know, or at least minimize the outcomes, or minimize the chance that, you know, you're going to be coming by and visit a doctor due to some back pain or due to some spine degenerative issue that's mainly going on. You know, you're basically trying to minimize your visits as much as you can with the doctor in regards to that back pain issue at the very least, so you be able to really treat your back well and better. And strengthening is one of the key points that you're trying to make sure that your back is well off and definitely in good shape. So I might post that later in the coming weeks, you know, who knows. But some very, very interesting stuff. I will definitely let you know in future videos if anything does pop out in regards to your dataset, or with respect to your dataset, anything that mainly pops up within that, I will definitely let you know. And I'm going to leave it at that, ladies and gentlemen. Chris and Paul from Nerd Chronicles is signing out. Deuces.